Hello, my name is Mark Richardson. I'm the lead field application engineer at LDRA, and together with Greenhill Software and ST, we're putting together a number of seminars entitled Software Defined Vehicle Development, Mastering Speed, Safety and Security. Now, next to my laptop at the moment, I have this evaluation board that has been lent to me very kindly by ST. And on this evaluation board, we have a stellar device here. In order to be able to communicate with this board, Greenhills have also very kindly lent me this debugger. It's a probe version 4, and as we can see, it's connected via the JTAG port. Now, the stellar device that we're using is an SR6 P7. It has quite a number of different cores. And if you want more information about this, then you can always go to the web and find information on it. In order to be able to run a program on this board, what I'm using is the Greenhills u-velOSity RTOS. And once again, if you want more information on this, then please go to the web and you'll find information on it. Now, the starting point is I've used Greenhills Multi in order to be able to create a project. And I've created a project based on the u-velOSity operating system, and I've targeted this stellar device. We can see here the source code that I've written. Let's take a look at the main. So inside the main, first thing we can see is I'm using the u-velOSity API, and what I've done is I've created a number of tasks. So here we can see I'm creating 3 tasks, 2 of which are communicating together with a mutex, and the third one here is basically going around in a loop, calling some functions, printing some characters out, and after a certain time it's going to halt the other tasks, and then we'll stop here. So let's go and build this. So let's go and do a rebuild. Okay, and there we can see that it's successfully built. And now let's go and download this to the target. So there we can see I'm going to see the source code. I'm going to put a breakpoint when we come to here. And now let's download to the target using the probe. So let's connect to the board, and that will take a little bit of time as it initializes the target, and then it should download the program into RAM, and then I'm going to be able to start executing it. Right, so let's go and run this, and I'm going to switch to the IO view, and we should be able to see that there we have the 3 tasks all printing out different characters, and at a certain time it then stops and it's hit my breakpoint. So I've got my source code. I'd now like to be able to, well, see is it compliant to ISO 26262 ASIL D. And that implies I need to first of all check that my code complies to a coding standard such as the MISRA C 2023. I want to check the quality of the code, ensuring it's not over complex. I want to be able to execute the code and measure the structural coverage. I also want to be able to unit test each individual function, specifying particular inputs and checking I'm getting the expected outputs. I'd also like to make sure that my code is not just safe, but also secure. So let's go and stop this. And now let's go and switch to TBvision. In this particular case, I'm using the LDRA productivity package for Automotive. And what I've already done to save time is I basically read the Greenhills project we've just been looking at. And from that, I was then able to analyze the source code. And now we're going to be able to take a look and see, well, is this code compliant to a coding standard? Well, the coding standard I've chosen is the MISRA C 2023. And as we can see, well, my code is not compliant. We have a number of violations. We have one here. In fact, we have 4 violations. Call has execution order dependent side effects. Well, let's double click and see where that occurs inside the code. So here we can see I'm basically calling the function roll dice 4 times, and this is all on the same line. And when I wrote this, I expected it was pretty obvious that it would call this one first, then this, and finally that. But actually what the C language says is the compiler is free to execute these in whatever order it wants to. And I've noticed with some compilers, it actually executes this one first, then this one, and of course I end up with a different output. So I could basically rewrite that. Alternatively, in this particular case, I'm going to justify that. So I'm simply going to right click on here, and I'm going to justify that particular violation inside this function. And I'm going to put a very simple justification in there. I should of course put a lot more text in, but just to save time, there we can see I've justified and excluded that violation, and it's gone. If I wanted, I can show the violations I have excluded, and there we can see they're grayed out. And there's also some other violations that have been grayed out. Once again, if I double click, this takes me to the source, and there we can see in this particular case, another way of excluding violations is to put a comment into the code. So two different ways of justifying violations. Either put them into an external ini file like I did here, or put them into the source code. Right, well, let's see if this code is compliant to MISRA. Well, we know it's not, but we could still generate a report against MISRA C 2023. So let's go and generate that report, and as we can see, we're not compliant. We have one guideline that's been violated, and we've got 10 violations. If I scroll down, I should be able to see in red we have a required rule here, and that's something that I need to address. Well, we have excluded some violations, so we can go into here and take a look, and there we have the dice.c, and there we've got the exclusions. So we can see there is the comment that I added in, and as we can see, that has now excluded 4 violations with one simple little rule. Let's take a look at the annotated code. Let's take a look at printer.c, and there we can see we've got some violations. We can see very clearly the violations. In this particular case, it says there's a void function, has no side effects. Well, I'm probably going to have to tell it what u-velOSity actually does, and then that violation would go away. Okay, so that's I should be able to make sure my code is compliant there to MISRA. What about the quality of the code? Well, let's go and open a system call diagram, and on the system call diagram, let's put this into a view that shows me metrics. For instance, I might be interested in viewing metrics such as cyclomatic complexity, and I can sort, and I can see here the value of the cyclomatic complexity for each function. Well, let's take a look at this one here. This has got a value of 3. What does that mean? Well, if we take a look at the paths through the code, these are blocks of continuous statements with branches between them. And if we take a look at this, we can see there's effectively one path here. There's a second path and a third path, and that's why that has a value of 3. These have got a value of 4. This one's got a value of 9. So it looks like my code is not over complex. That's good. What I'd now like to be able to do is to execute the code just like we did earlier. And as it executes, I'd like to find out, well, which of these blocks have we executed and which ones have we not executed. So what we're going to do is we're going to put probes into each block of continuous statements. So if we put a probe at the start and a probe at the end, and we hit both those probes, then we know we've executed all these statements inside here. So let's go and perform that. So I'm going to simply press on this button here, and that is going to perform what we call the dynamic analysis. So this is going to instrument the source code. It's then going to perform the build. It's now downloading to the target, and it should behave exactly the same as we saw before. So let's switch to the IO view, and there we can see, yes, we're getting exactly the same output as we saw before. So once again, it's going to hit the breakpoint. It's then going to stop. It's going to upload the results, and then we're going to be able to find out, well, how much of the code have we actually exercised as that ran. So just need to wait for this to finish. And now, well, lots of ways we can view the coverage. Once again, I'm going to the system call diagram, and this time I'm going to put it into a view that shows us the coverage. And we've got statement, MCDC, and also branch coverage. And let's take a look and see where we've got the coverage. So we'll start with integer to ASCII. Let's view a flow diagram. And there we can see color-coded in green are the blocks of code we've executed. In red, the blocks of code we haven't executed. And in yellow, we've got a block that, yes, we've executed it, but we haven't exited by every path out of that block. So very clear to understand the coverage we've obtained. Let's take a look at task ping run. And again, we can see we haven't exited this loop. We also haven't executed this block of code here. We never got the message task ping has waited too long. What about main? Well, main is interesting because it looks like we've only got 91% coverage because we have this UV kernel start and the code never ends. So it never executed this line of code here. So that's something I could actually justify. So let's go and justify why we haven't got 100% coverage. So what I'm going to do is I'm going to do a code coverage view of just where we haven't got the coverage. And if I scroll down, I should be able to find main. And I'm going to justify here by going to that menu. And again, I'm just going to put a very simple justification in there. And there I'm going to get it to update the coverage. Let's apply the justification. And we should see that now main is compliant. Good. So what about, well, integer to ASCII, we didn't get 100% coverage. So what we could do is we could complement that by using TBrun. So TBrun is our unit testing tool. And I've already created some sequences for testing this integer to ASCII function. So I'm simply going to go and find it, load it, and now I can see I've got a number of test cases with different inputs and expected outputs. So let's go and execute that and see what happens. So that's now generated a program, it's built it, it's downloaded it to the target, we're running on the target, we're going to get the results back, and hopefully we'll find that all our tests have passed. So okay, that's just uploading the results now, and there we can see yes, all my tests have passed. And let's go and take a look at the coverage. There we have the integer to ASCII function. So previously we had 79% statement coverage, 25% MCDC. Now we can see on this particular run we've got 100% coverage, and of course the combined coverage is also 100%. Now something else I can do is I could go and load another sequence of test cases that I've created previously. And these I'm interested in the timing. So I'd like to find out, as I execute this function integer to ASCII, I want to find out, well, how much time does it take to execute? So I'm going to execute this 250 times. I'm going to specify different inputs. I don't care about the outputs, but I want to time how long it takes to execute. So let's go and run that. Now this is going to take a bit of time to execute because basically it's executing 250 times, and each time we need to upload the results and of course the time that it took to execute. So just wait for that to start executing, and there we can see it's now uploading the results, and then afterwards we're going to be able to see how much time did that function take to execute. In this particular case I'm running on just a single core, but if I was running something else on other cores at the same time, then I would expect the execution time to probably increase. Well, let's view a worst case execution timing diagram. And there we can see that the time we've measured is between this point and that point, and the good thing is it's well below the worst case or the possible execution time that I've specified here. So that's looking good. Okay, so that's all looking pretty good so far. What I'd now like to be able to do is let's go and generate some reports. So let's go and generate here, let's generate an ISO 262 ASIL D report. Okay, let's wait for that to start. And there we can see we have, first of all, our ISO 262 compliance report, and some of the aspects we're able to check with the LDRA tool suite. So for instance, enforcement of low complexity, that's passed with measured metrics like the cyclomatic complexity. Enforcement of use of style guides, that's failed. We've got quite a few violations, so that's something that I can address. What about HIS metrics? So we've measured metrics on the code, and here we can see we have one particular problem. Let's scroll down and take a look. And there, if I go into main, we can see we have a number of called functions has failed. If I scroll down, we can see we've measured 8 and 9, and the threshold I think for this is set to 7, and that's why that's shown as failed. So again, I could address that. We've got our unit tests, we've got the code coverage, we've got function coverage, we've executed every function, that's good. Call coverage, well, there are some functions we've not invoked from everywhere where they can be called. If we go into here and scroll down, we can see we haven't called printer print from this particular point inside the source code there. Okay, so that's looking pretty good. So what I'd now like to be able to do is to automate everything that we've done. So what I'm going to do is I'm going to close down this. I'm going to go into here and I'm going to run a batch file. So this batch file is going to basically automate everything we've done so far. And if you want to use a continuous integration system, then it's very easy to integrate into that. So if you're using Jenkins or Azure DevOps, then you can basically use our command line in order to be able to execute the tools and get the results back. Now this is going to take a little bit of time to run, so I'm going to fast forward until the last test case and we'll carry on from there. Okay, so we have 9 test case files. We can see the first 8 have all executed and they've passed. We're now executing the last one. So once again, we can see we're downloading to the target, we're executing, getting the results back from the target, analyzing the results, and hopefully we should find this test case also passes, which it does. We're now performing the data coupling, and then we're going to do the justification for where we don't have the coverage. And finally, we're going to generate a large number of reports. We don't need all the reports, but there's a lot of reports that we can generate. Okay, so first of all, we have the test manager report. That's just a quick overview here. So we can see in this particular case, code review, it's all green, quality, all green, test verification, we've got 100% statement, branch, and MCDC. And then all our unit tests, all our sequences, they've all passed, and that's good. Okay, what about the standard model compliance? Well, in this particular case, we are 100% compliant to MISRA C 2023. So that's good news. But there may well have been some places where we've had to exclude some violations. So very important to be able to see where we've done that. And there we can see we've excluded the violations in the dice, roll or dice. This is one where I put a justification as just okay. Now we can see I put a more interesting justification in there. If you wanted, we could actually dive in and take a closer look, and there again we can see the same justification that we added in earlier. So that's good. The code is compliant to MISRA C 2023. What about the guideline compliance summary? We're taking a look at that. What about the ISO 262 compliance? Well, in this particular case, we can see now we are compliant for enforcement of strong typing. We're also compliant now for the use of style guides and naming conventions. And if I scroll down, we should be able to see more places where we've been able to provide the compliance there. And we should be able to see here, we've got the statement coverage, branch coverage, MCDC, and a bit lower down, we should also have the function coverage and call coverage. So let's take a look. And what about the HIS metrics now? Well, we go into the HIS metrics. We can see at this point we're now 100% compliant, and what I did in this particular case is I just changed the threshold for the parameter that was failing. So that's compliant. That's good. What about the coverage? Well, we could start off by taking a look at maybe the function coverage. Well, we've already had 100% function coverage. Call coverage, we've now got 100%. What about the code coverage? Well, as we saw, again, we've got 100% coverage. And if we wanted, we could dive into here and get more information line by line exactly of our coverage we've obtained. Good. But again, the code coverage, there may be some places where we've had to justify where we didn't get coverage. And in fact, we've got 2, 3, 4 places where we've justified that. And if I go into here, we should be able to see that each time it's basically in the main because it never ends, and also inside each root of a task because they as well never ends. So that's a suitable place where I can justify my coverage. Finally, what about security? Well, MISRA already checks for safety and security in the MISRA C 2023, but we can take some additional checks here. We can take a look at the security vulnerability. In this particular case, we can see, well, we have no vulnerability, so that's good news. We could take a look at a security review. And in this particular case, we've got no CWE weakness violations, and we've also got no CERT rule violations either. So that's looking good. And finally, we could take a look at the taint analysis. And in this particular case, we have no taint sources, but we do have some taint sinks. So that's looking pretty good. Okay, so if you'd like more information, then please don't hesitate to contact LDRA, Green Hill Software, or ST. Thank you.